Hello, Algebra 1 students. This is Mr. Scheidegger. As you can see, I'm not here today, and I will be giving my lesson through this YouTube video that you're watching now. And we will be moving to Chapter 6.1, Simplifying Fractions. And here we're going to be using an awful lot of our understanding of factoring. So during the class, let's make sure you work together so that if you forget anything, then you're able to ask someone to help you to make sure that you can continue, that you can factor and solve these problems. Once we get started, if your factoring is still pretty strong, you're going to be in pretty good shape, and it should be that way because a lot of you did pretty well on that test. If you didn't, we just need to practice some more. So what I'm going to do today is, if you do have a book, you can go to page 248. And what I'm going to do, is several of the problems that you have for homework. So if you look on my essay, you're going to see that we have several questions from page 248. And what I will be doing is questions 1, 4, 9, 13, 21, and 27. These are all homework problems for you guys. So if you follow what I'm doing, you can use what I'm talking about to solve these problems. I want to see the work. All right, I want to see the work. I do not care to see answers, especially for odd questions. So what we'll do is get started. Before we get started, though, let me just go ahead and I'll title the section. This is 6.1. And actually, let me pick a more noticeable looking color here. 6.1. And the title is just Simplifying Fractions. There's a couple things that are going to be useful tools for us to simplify fractions. One of them is recognizing binomials that are opposites. So every once in a while, you're going to see a binomial that will look like something like x minus y. And then we will see another binomial that, say, y minus x. As you can see, the x from one binomial to the other has become negative. So we have a positive becoming a negative, and the negative y becomes positive. So what we say is that these are opposites. The x on the second one, on this point here, is opposite the first one, and then the y is also opposite the other one. So what does that mean? Well, if we have opposites over opposites, that usually means, say, like a negative 5 over a positive 5. We usually get, well, we always get, would be a negative 1. Similarly, if we had a negative x over a positive x, we would also get negative 1. So it's worth recognizing that if I have, say, let's see if I can move this down a little bit. If I have x minus y over y minus x, well, guess what? I just told you that these are opposites. Remember, the x on the top is positive, the one on the bottom is negative. The y on the top is negative, the bottom one is positive. And if you're seeing that it just looks like the same binomial with the letters switched, well, guess what? That's exactly what it is. When you see the letters switched, it has to be a minus sign in the middle, and you see the letters switched like that. Basically, what we have is two numbers that are opposites. So we can cancel those out, but we just need to make sure that we recognize that creates a negative 1. So let's go to another page, and let me show you how that deal works. So say I have 2 times y minus 3 over 4 times 3 minus y. Well, we can reduce this fraction and we can simplify it. First step is we can see that there's a 2 and a 4 which both share a 2. So let's divide the top by 2, and we get 2 divided by 2 equals 1. 4 divided by 2 equals 1. And again, we look at the y minus 3 and the 3 minus y, and we recognize that they are opposite. So we can cancel those out, but we need to remember, because they're opposites, that it leaves us with a negative 1. So our final answer will be, oops, sorry about that. This here should have been a 2, right? 4 divided by 2 is 2. So apologize for that error. So anyway, the final result is negative 1 on the top and a positive 2 on the bottom, which is the same as just negative 1/2. So I just want to throw these in there. This is just one little tricky piece that you're going to see in this that we've not seen in the past. Okay, now I am going to go to the problems. You should have a sheet of paper that has the problems that you're going to be doing for homework, and you can also find them on my essay. So what I encourage you to do is to follow along as I go along. You should have your own piece of paper, and you should have your own and a pencil so that you can do the work. I don't want you to do the work on the sheet with the homework problems on it, because there's just not enough space for you to do it appropriately. So remember that there's paper in the back of the room underneath the hole punch. So if you need paper to do your homework, please go get that, and go get it now. Otherwise, take some paper from your notebook so that you have something to work on. I want you to be able to do this work. If you want to, you can just follow along and copy down the work that I do. You're going to copy it down on your paper so that you understand it. But what I would really love for you to do is, when you get a hang of things, see if you can't move ahead and do it on your own. And that way you may not have to listen to all of me all at once. But if you get lost, then you can go back to this video, listen to a problem that's similar to the one that you're confused on, and see if you can't solve it. So with that, what I'm going to do is I'm going to move through some of the problems that you do have. And if you want to pause and do a couple on your own, I'll tell you when you can pause and try to do that, and then we'll keep working through. So if you haven't finished by the end of class, I want you to just you'll have the link to this video on my essay, and you can just complete the work from there. So I'm going to next page. I'm going to do 1, and let me show you how we do number 1. This is again, this is page 248, and we're going to do written exercises, everybody, right? Number 1, and the problem is 2x plus 2y over 4. Now, just a reminder that on the top we have 2 terms. So, and we have one factor. So what we need to do is to factor it to see if we can't create more than one factor, and see if there will be a common factor that we can cancel out. If you notice, there is a 2 on both of these terms, which we can factor out. So we're going to write 2, and then we divide everything by 2. We get x plus y. And if at any time you're not sure exactly what's going on, please pause and then think about it or replay it. The bottom will still be 4. And now that we have everything factored, we have 2 factors on the top and we have a 4 on the bottom. So now we can look for a common factor. Well, there's a common factor of 2 in both the numerator and the denominator. I divide the top by 2 and I get 1. And I divide the bottom by 2 and I get 2. Final answer will be x plus 2 over 2. Okay, now let's, if you want to, you can consider pausing and looking at number 3 and seeing if you can do that one on your own. If not, you can continue listening to me, but I would encourage you to pause for right this moment. See if you can't do number 3, and turn this back on, and we'll move to number 4. Okay, so if you did number 3, you will hopefully have gotten the answer 5. And the book also writes that A cannot equal 2. We'll talk a little bit more about that later, but right now I'm going to move on to number 4. And because you can replay this, I'm going to see if I can move a little faster for you. Also, just so you know, if you're on YouTube, which you should be, and you go to the settings, if you feel that I'm talking too slow and you want to move faster, just go ahead and increase the speed of the playback. I'll sound a little bit more like Mickey Mouse, but hey, it'll move you to a little quicker. Number 4, 4n plus 16 over n plus 4. So again, we need to factor both the numerator and denominator to the best of our abilities. The numerator has a common factor of 4, which we can take out and write as 4 times n plus 4 over n plus 4. And if we cancel out the n plus 4 on the top and the bottom, we get a final answer of 4. Any questions on that? How are we? So, and I believe that is the correct, yes, it's the correct answer. All right. At this point, you may consider, because the next one I'm going to be doing is number 9. So you might consider doing number 6 now. I'm walking you through this pretty slowly. Again, pause and do number 6. And when you're done with number 6, I'll tell you what the answer is and see if you got it right. Welcome back. So if you did number 6, you should have gotten the answer of number 6 was, the answer is, I'm sorry, I should have had that, x minus y over x plus y. These are not opposites. If you look, the y's are opposites, but the x's are not. So that's it. That's the final answer for number 6. And all right, so but I'm going to erase that because I want you to be able to be doing that on your own, and you could check that. So let me move on to the next problem. Next problem for us that I'm going to be doing for you is number 9. So as we go, we're going to get a little trickier. Number 9 is, let me get back to my pen. I guess I'll try white. Looks pretty cool anyway. Number 9 is 2xy divided by x squared y minus y squared x. So you'll see that the numerator can't be factored, but the denominator actually can. If you look at these two terms, you'll notice that they both have at least one x and they both have at least one y. So we should be able to factor out an x and a y. So the numerator is going to stay the same. It's going to be 2xy. I factor out an xy. This is tricky, I know, but it can be done. Now I divide both of those terms by xy. And if I divide the first term by xy, I get an x. And minus, now I have to divide the y squared x by xy, and I get a y. So again, if that looks a little confusing, go ahead and place back a couple times and see if you can figure out how that works. But now we have some common factors that we can divide out. We have an x on the top and an x on the bottom. We can divide by x there and x here. We get 1. Divide the y, 1, 1. And so what are we left with? In the numerator, we have a 2. And in the denominator, we have an x minus y. And that is your answer. So at this point, again, encouraging you to go ahead and move forward here. I would probably tell you to do, let me see here. The next one for you to do is number 12. So if you could take a moment and look at number 12. Now, number 12 is your first question that actually has an opposite in it. So be warned that that's the case. And let's see if you can get that question right. And pause this, pause this for a moment and put the number 12 on your paper and see if you can't solve it. Okay, so hopefully by now you'll have number 12 done. One of the things you should have noticed is that the x minus 5 and the 5 minus x are opposites. So you can cancel them out and it becomes a 1, negative 1. The 2 plus 7x in number 12 and the 7x plus 2, believe it or not, are actually the same. They're both positive on the top and they're both positive on the bottom. All we did was change the order of them. So yes, you can cancel them out or divide them out and you would get 1. The final answer for number 12, surprisingly, is just the number negative 1. If you didn't get that, you can go ahead and look at it again and see if you can't figure out exactly why. But again, it's the x minus 5 divided by the 5 minus x. You can divide those out, but you need to leave a negative 1. And the 2 plus 7x and the 7x plus 2 just equals 1. So if that's still confusing for you, wait till I come back tomorrow and we'll talk about it. So let me erase this one for now and we'll go to our next problem. Our next problem is number 15. No, I guess it's number 13. Sorry about that. So number 13. And that is, finally we get some things that we really have to factor. We have a squared plus 8a plus 16 divided by 16 minus a squared. So some factoring here. So let's go ahead and factor the top one. And just on this one, we need to, if we want, I'll just take it off to the side for a moment here. Plus 8a plus 16. If you want to, you can go ahead and try to split the middle. Well, let's go ahead and split the middle term. I think some of you know that there's kind of a shortcut with this one. Basically, with anything that has the squared term is all by itself, we can just we can factor it. Actually, I'm going to see if I can get you to do this. We can factor it this way. If there's just a 1 here, all right, not a 2, not a 3, not a 4, what we can do is just put an a here and an a in the front. And then, again, we're going to be looking for two numbers that multiply out to be 16 but add up to 8. Those two numbers, if you think for a while, will be 4 and 4. So the answer to this is actually a plus 4 times a plus 4. So that's the shortcut. I feel like I want to go ahead and do it as a splitting of the middle term, just to make sure that some of you guys don't get confused. But if I do split the middle term, I'm going to get a squared plus 4a plus 4a plus 16. And I factor out from the first half an a. I get a times a plus 4. And I'll take out a 4 from the other one. And I get a plus 4 again, as I should. And so I get a plus 4 times a plus 4. The 16 minus a squared in the denominator is going to be a difference of two squares. Hopefully you haven't forgotten what that is. So to do this, I take the square root of the 16 and I put it in the front. And then I take the square root of the a squared, and I put it in the back. And I make one plus and I make one minus. So now I've got this for my numerator and I've got this for my denominator. I know that was a lot of work, but let's go ahead, put it all together. All the hard work is done. Now we just need to finish. So we got a plus 4 times a plus 4 on top. And on the bottom, we have 4 plus a times 4 minus a. So now let's be careful. There's no opposites here, but there are two terms that are the same. Can you tell which ones they are? What was that, Rita? Yes, you're right. The a plus 4 and the 4 plus a are actually the exact same thing. They're just in different order. The a plus 4 and the 4 minus a are not opposites. Just look. The a's are opposites. One's a and one's negative a, but the 4s are both positive. So there's nothing we can do here. They're not the same term. Final answer, therefore, is going to be a plus 4 over 4 minus a, and that's it. So with that, the idea is that you should pause and do number 15 and 18. So see if you can't do numbers 15 and 18, and we'll come back and I'll give you the answers to those two, see if they check, and then we'll move on. Okay, I'm going to hope that you didn't get tricked on number 18. It was it made you think, if you're not careful, it gave you the impression that you might have been able to cancel the binomial on the top with the binomial on the bottom. But remember, we can only cancel factors, and those are not factors the way they were set up. So the answer to number 18 is actually 5C. This is number 18 is 5C plus 3D over 2 times 5c squared plus 3d squared. And I'm just hoping that you see that, there may be a temptation to think that these d's can be reduced or these c's can be reduced. But remember, these are numbers that are inside a binomial. We really can't touch anything that's inside those binomials. They are factors of themselves. And again, just think of it this way too. If you look at the top, if you look at the numerator, that is one factor made of two terms. And on the denominator, we have two factors, one binomial and one monomial. But none of them match. Therefore, there's nothing we can do. The next question is number 21, not 21. I didn't do number 15 for you. Number 15, the answer to number 15 is, let me make sure I got this right. All right, that should be minus 1 over y minus 2. So I did do that in my head because the answer isn't right there. So number 15 should be a negative 1 over a y minus 2. Okay, so I'm going to erase those, and I'm going to move to our next problem, which will be number 21. Okay, here we go. Number 21. If you can, see if you can't get ahead of me, that would be great. But I got 3x squared plus 6x over 6x squared plus 7x minus 10. The top part is pretty easily factorable, believe it or not. There's, can you look at that number on the top of 21? what is it that they both possess? They both possess a 3. Both terms have a 3, and they both have an x. So the numerator will look like 3x times x plus 2. Again, you have a pause button to take a moment and make sure that that's correct. This is a little bit more work here, as we got the 6x squared plus the 7x minus 10, and we're going to have to split that middle term. There's no greatest common factor either to get out of here, so we're just going to have to, we're stuck with what we have. The 6 times the negative 10 gives me a negative 60, and then my middle term is going to be that 7. So two numbers that multiply to 60, negative 60, and add up to 7, to add up to a positive 7. So again, if you get stuck, let's think about all the ways that we can multiply to get 60 and see which one has a difference of 7. Why do I say difference? Because the numbers have to be opposite if we're going to get a negative 60. So let me go 1 and 60. We have 2 and 30. We have 3 and 20. Moving on here to 4 and 15. And also 5 and 12. Well, did anyone see it? Okay, yes. If we make the 12 positive and the 5 negative, we get the positive 7 that we're looking for. So negative 5, positive 12. And let's go ahead and split this term. So instead of a 7x, we're going to have negative 5x plus 12x, which add up, of course, to 7x. So the term has not changed. This quadratic has not changed. This expression hasn't changed. So now it's take out. It looks like we're going to have to take out an x from the first term, from the first half. That's all they have in common. So it's going to be 6x minus 5. And it looks like we're going to have to take out a 2 on the second half. So a positive 2 times 6x minus 5. Yay, the binomials match. I take out the 6x minus 5. And I'm left with an x plus 2. So that was a lot of work. And now though, I have a denominator for this term, and it is going to be 6x minus 5 times x plus 2. And you will happily see that we do have two factors that match. The x plus 2 and the x plus 2 go. We divide them out so they get 1 and 1. And so the final answer is 3x over 6x minus 5. Done. Now, that means that you have one to do, and that would be number 24. And I'll invite you to try to do number 24 while I pause this, and I'll give you the answer shortly. Okay, so if you did number 24, your answer should have been a negative 2y minus 1 over 2y. Can I cancel the 2y's? Absolutely not. Remember that the numerator right now is a single factor made of two terms. The denominator is a factor of 2y. So because those two factors are not the same, we can't cancel them. So moving on. Let me erase that. And what I'm going to do with 27, that's the last problem, and it's also one of the more challenging ones, is I want to start you off and see if you can't finish, and see if you can impress me by that. So number 27 is the last question on the homework that you have tonight. Is it's going to be r squared minus s squared over 4r squared plus rs minus 5s squared. So my hint to you is that the top is a difference of two squares. I'm hoping that you can figure out how to factor that on your own. I will start you, though, with the factoring of this problem, the 4r squared plus 1, if you will, rs minus 5s squared. We're going to split the middle term because we always want to split the middle term if we ever have a number that's bigger than 1 in front of the r squared. So in this case, where the top number is going to be 4 times negative 5 or negative 20. And the middle term is 1. Two numbers that multiply to negative 20 and add up to 1 will be 5 and negative 4. So we split the term, 4r squared plus 5rs minus 4rs minus 5s squared. Again, 5rs and negative 4rs need to add up to that 1rs. So I'm going to do almost to the end here. I'm going to break this up, and I'm going to say they both have an r term. So I'm going to take out an r, and I get 4r plus 5s. On the next one, because there's a negative sign here, I'm going to try to take out a negative 1. That's a negative 1s. So I'm just going to go negative s. I'm going to take that out. Now watch, the signs have to change here when I do this. When I take out the s, I'm going to get a positive 4r. And I take out the negative, if I divide by negative s for the third term, I get plus 5s. So again, take a moment. I say I kind of did that pretty quickly. So recognize why those negative signs, the negative 4r, those last two terms turn into a positive. And I'm going to let you go to that one last step, tell me what the factors are, and then you can go ahead and slide them in here. Now I'm going to trust that you can factor the difference of two squares and factor that and see if there's anything that is the same. And then you'll give me the answer when I come back on Tuesday. So that's it for now, everyone. I know that's pretty long. But hopefully by tomorrow you'll be able to do some more of these. I'm going to add just one little important piece, and that is the importance of making sure that we never allow the denominator to equal 0. But that's going to come up, that'll be coming up again tomorrow on Tuesday. We'll talk about that. Until then, everyone, I hope you have a good night, and I will see you tomorrow. Bye now.